Okay, so this video is a revision video on the trig ratios. Okay, so here they are. This says that sine of the angle is equal to the opposite side divided by the hypotenuse side. Cos of the angle is equal to the adjacent side divided by the hypotenuse. And tan of the angle is equal to the opposite side divided by the adjacent. So what this means is that whenever you have a right angled triangle, no matter what size the right angled triangle is, sine of the angle in question will always equal to the opposite side of that angle divided by the hypotenuse side of the triangle. Okay, so in effect, there are three formulae, if you like. Okay. And one of the key things, of course, is the fact that they can only be used if it is a right angled triangle. So similar to Pythagoras in that effect, but how you know to use trig ratios over Pythagoras the minute you see a right angled triangle is because the minute there is an angle involved in the question, that's how you know you have to use trig ratios. Pythagoras, remember, is all about the sides, when you're given sides looking for a side. But trig ratios, the minute there is an angle involved, that's how you know to use one of these three little formula, if you like. So use when you have a right angle triangle and when there is an angle involved in the question. So the first thing you need to be able to do the minute you see that you've got a right angle triangle, you have an angle involved, is label the sides. You need to figure out which side is the opposite side, the hypotenuse side and the adjacent side. Okay, so let's take this right angle triangle here. We've already come across the hypotenuse side in a right angle triangle when we went through Pythagoras. If you haven't looked at that video, do check it out, okay, the video on Pythagoras. The hypotenuse is, of course, always the longest side, the diagonal, the side that is opposite the 90 degrees. So that's the first one that we can fill in straight away. Okay, so there's your hypotenuse side there straight away in this particular triangle. Now, after that then, it depends on which angle is involved in the question. So this is the angle, let's say, in this particular triangle that we're talking about. So the opposite side to that angle is going to be this side here, directly opposite the angle. Okay, so depending, as I said, what angle is involved in the question, the side that is directly opposite is the opposite side. All right, so that's kind of self-explanatory. And then that leaves us with the adjacent side. Okay, and it is easiest to fill it in probably the hypotenuse first and then figure out which one's opposite, and then you know the one you're left with is the adjacent side. The adjacent, though, just to make it a little bit easier for you to understand which side that always is, adjacent in English is another word for beside. Okay, so it is the side beside the angle. Okay, so that's why it is called adjacent. It is the side length that is beside the angle. Okay, so that's always what you're going to want to fill in first. Which sides have you got involved in the question? Labeling those sides is the first thing you're going to do. We'll take a look at that now when we go through some examples together. First thing I want to show you, though, is where we can find information about the trig ratios in the log tables. Okay, this appears on page 16 of the log tables. All right, the only thing about it, though, we can see quite clearly it's under the right angle triangle, and it's here with Pythagoras' theorem, and we've got our sine, cos and tan, but they don't have it labeled the way we will use them, okay, which is a little bit unfortunate. But if we analyze the triangle that I have, I can see that sine A is equal to the small a over the c. And the small a is, of course, the opposite side. And the c is, of course, the hypotenuse. So in a roundabout way, it is telling me that sine of the angle A is equal to opposite over hypotenuse. Cos of the angle A is equal to B over C. B, of course, okay, so it's similar to the triangle I have here, is adjacent. So B is the adjacent side over C, of course, is the hypotenuse. So again, it's telling us that cos of the angle is adjacent over hypotenuse. And lastly, tan of the angle is equal to the opposite. The side of A is opposite over the adjacent B. So in a roundabout way, it is telling us opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So really, you do want to be really familiar with the way these are, okay, using the OH, AH, OA, but in the log tables, it will give you enough information to just trigger your memory there, okay? A good way of remembering this is to think of it as SOHCAHTOA, remembering all your letters. Another good way of remembering it, if you remember the order of sine, cos and tan, as of course it's given in the log tables, it's given sine first and then cos and then tan, is oh hell, another hour of algebra. That one might stick in your brains a little bit more. But anyway, just so that you're familiar, as I said, you need to be very familiar with those three little ratios. Okay, let's jump straight into some examples and we'll see how these work. Right, let's take a look at this right angle triangle here. And of course, immediately we see there's an angle involved. That's how I know it's going to be one of my trig ratios. All right, but which one, I don't know yet. Now, if you're feeling confident at this point, why don't you press pause and see if you get this right. Otherwise, listen carefully. I'm going to go through the steps that you need to think about in order to figure out how to find the length of side X. So the first thing I'm going to do, as I mentioned already, is label the sides, okay? So what sides am I dealing with in this question? Well, obviously I'm giving this 12 centimeters. So I will want to label this side. So that side there is your longest side, your diagonal side, opposite the 90 degrees. Straight away I know that that is the hypotenuse, okay? And now, of course, the side that I'm looking for is this side over here. So this side, is it the opposite or is it the adjacent side? That's what you want to figure out. And given that it is directly opposite that angle, it is, of course, the opposite side. Now, there's no need for me to label this side here because it's neither given to me nor am I asked to look for it, okay? So all I need to do is label the sides that I'm given or looking for. So I've got O and I've got H. And now you've got to think about, well, which of my trig ratios, sine, cos and tan, connects the angle, the opposite and the hypotenuse? And it is, of course, if we look back up here, sine. Sine is the one that has the angle and the opposite and the hypotenuse side together in the ratio. So that's how I know that that's what I'm going to use. So the first thing I'm going to do is take it down just as you would a formula. Sine x is equal to opposite over hypotenuse. And now we'll fill in what we know. So we've got sine, and now the next thing we can fill in is the angle. And the angle quite clearly here is 30 degrees equals the opposite side, and here my opposite is labelled x, divide by the hypotenuse side, which here is quite clearly 12. Okay? And now, just as you would with any equation, you want to get x on its own. Now, the way to get x on its own is to get rid of the divide by 12. Now, how do we get rid of divide by 12? Well, what we can do to get rid of divide by 12 is multiply by 12, okay? If you multiply by 12, that will get rid of the divide by 12, which is exactly what you want. You want to get the x on its own. But of course, given it's an equation, if you times that side by 12, you have got to times that side by 12. So what I want to do on the left-hand side is do 12 times sine 30 degrees. And that will give me the value for x. Now I've got x on its own here on the right hand side. So what I'm going to do now is I'm going to put that in on the calculator. So I type in 12 times, and then there's sine, do you see right there? And then I'm going to put in 30 close my brackets and press equals, and the answer should be 6. Now if you're not getting 6 on your calculator, just do a double check that you are in fact in degrees, okay? It's really important that you're in degrees. On the Casio calculator, to double check that you are in degrees, if you press shift and then set up, okay, you can see it comes up here. 3 is the option for degrees, 4 for radians, 5 for gradients, and you've got all these other different options. With higher level maths at Leaving Cert, you'll deal with some radians, but if you're not doing higher level maths at Leaving Cert, then you only have to worry about your calculator ever being in degrees. So we're going to pick number 3 option. A little d should come up here, okay? And now try it again. 12 times sine 30. I was in degrees to start off with, so we should still be getting 6, and I am. So if you didn't get 6, try it again now. Put your calculator into degrees and now check that you are getting 6. So 6 is the answer. And of course, what units are we talking about? We're talking about centimetres. So x is equal to 6 centimetres. Okay, so let's take a look at this question. So if you're feeling confident, press pause, see how you get on. So we've got a right angle triangle here, and I have an angle involved. So immediately I know I'm dealing with trig ratios. But which trig ratio? That's the question. So let's see what sides we're dealing with. So the first side I can see I have here, I'm told is 18 centimetres, is this side here. So which side is that? Given it's a diagonal and it's opposite 90 degrees, I know immediately, of course, that that is the hypotenuse. So I label it H. Now, this is the side I'm looking for. So now I'm concerned with what side this is. Is it the opposite side or is it the adjacent side? Well, given that it is beside the angle, it is obviously my adjacent side. So I want the trig ratio that connects the angle, the adjacent, and the hypotenuse. And of course, the trig ratio that does that is cos. Cos of the angle is equal to the adjacent over the hypotenuse. Right, so let's fill in our bits. Cos of the angle, well, the angle here is quite clearly 45 degrees. It's always the angle that goes in that part there. Equals, the adjacent side is here labeled x, divide by the hypotenuse, which is quite clearly here, which is 18. Okay, and as always, we want to get x on its own equals. How will you get x on its own? In other words, you want to get rid of the divide by 18. So what are we going to do? We'll multiply by 18. That will get rid of the divide by 18. But of course, if you multiply that side by 18, you've got to multiply that side by 18. So now, that's what I'm going to do on the calculator. I'm going to do 18 times cos 45 degrees. So let's do that on the calculator. 18 times, now here's where cos is, do you see it? It's right beside the sign here. So cos, and then put in 45 degrees and close your bracket and press equals. Ooh, so I've got 9 root 2. So what I'm going to do here, because it won't always work out to be a nice whole number, by the way. So what we'll do is we'll press our S to D button. And here we go. We have the decimal places. Let's do it to 1 decimal place. Always read carefully what it is in the question. But for the examples, we'll do it to 1 decimal place. So 12.7. Remember to always look at the number after. 2. 2 doesn't make it bump up. So we leave it at 12.7 and centimetres. Okay, so try this question, press pause, see how you get on. So we've got a right angle triangle here. We've got an angle involved, so we know it's trig ratios. And the first thing we're going to want to do is label our sides. Okay, so this time I'm given this 12 centimetres here. So what side is this? Well, we can see it's the side beside the angle. So that is, of course, the adjacent. And the side I'm looking for is here, and that one we can see is opposite the angle in question. So that is, the opposite side. All right, so it all depends on which angle is given to you in the triangle, okay? It's all about that angle. So which side is adjacent to that angle, which side is opposite that angle. So now we need to think, which of the trig ratios connects the angle, the opposite, and the adjacent? So go back and look at your trig ratios. Is that sine, cos, or tan? And if we take a little look, we can see here, it is of course tan. Tan is the one that connects the angle, the opposite, and the adjacent. That's how I know to use tan. So write that down for yourself, your little formula if you like. Tan x, the trig ratio, is opposite over adjacent. Right, let's fill in the bits we know. So we know the angle, it is of course 20 degrees. And the opposite, well, the opposite is labelled x, divide by, and the adjacent is of course 12. So 12. So now, again, I want to get x on its own equals. So what I want to do is get rid of the divide by 12. Well, to get rid of divide by 12, I'm going to need to multiply by 12 on that side. That will get rid of it and give me the x on its own, which is what I want. But if I times the right-hand side by 12, I have got to times the left-hand side by 12. So now on the calculator, I'm going to do 12 times, and here's tan, okay? See they're in a row here, sine, cos, tan. So press your tan, and it's 20 degrees, close your bracket, press equals, and we'll do to one decimal place again. So we have 4.3. Remember, always look at the number after. So that's a 6. That is, of course, going to make that 3 bump up. So I'll be left with 4.4 centimeters. Okay, so let's take a look at this question. So now we have a right angle triangle, and we do have an angle involved in this question. It's actually what we're being asked to look for. We're asked to find what that angle x is. So there's an angle involved in the question, which immediately means we've got to use one of our trig ratios, okay? So like before, first thing we're going to look to do is label the sides. What sides do we have in this particular example? So if that's the angle that we're talking about, then this side over here is the opposite, okay? And this side here that I'm given is of course the diagonal. It is opposite the 90 degrees, so this side of course is the hypotenuse. So what trig ratio is going to connect the angle, the opposite, and the hypotenuse? So let's look back at our trig ratios. Here we go. And the one that connects the angle, the opposite, and the hypotenuse is, of course, sine. So let's write that down for ourselves. Sine of the angle is equal to the opposite over the hypotenuse. Okay, so let's fill in what we know. So sine of the angle. Well, the angle I don't know, and it's just marked as x. So I'll put it in as it is, okay? Equals, now the opposite side I know is 20, divide by the hypotenuse side, which I know is 24. Okay, now here's where we have to solve for the angle, all right? We have sine of the angle x, and of course we just want to get the angle x on its own. So the question is, how do we undo the sine? So the only way to undo the sine is to do what's called the sine inverse. Okay? If I do sine inverse of my result, that will undo the sine and give me the angle on its own. So this is a particular calculation that we're going to do on the calculator. The sine inverse button is above the sine button. So the way we access it is by pressing shift, sine, and you see the way sine inverse comes up, sine and the -1. So that undoes the sine to give you the angle on its own. So sine inverse, and then I'm going to put in the fraction, and on the top I'm going to put in 20, and I'm going to come down on the bottom, I'm going to put in 24, come to the side, close the bracket, and press equals. And here we go. What I'm going to do with these answers, I'm going to, if I'm looking for an angle, I'm going to do it to the nearest degree. So the nearest degree here, well, I've got 56. Always look at the number after, remember, we've got a 0.4. 4 is not going to make it bump up, so we leave it at 56 degrees. So we have a really important thing to remember here, okay? So let's take it down as an important note. And that is that whenever you are looking for an angle, you must use either sine inverse or cos inverse or tan inverse on the calculator. And how you get the other buttons, the cos inverse and tan inverse, they are of course also above the cos and above the tan. So to access them, you'll press shift, there's cos inverse, and for the tan, shift, there's tan inverse. And you'll only use the inverse buttons whenever you are looking for the angle. Okay, so try this question. Press pause if you're feeling confident and have a go at finding this angle here. So we've got a right angle triangle. There's an angle that we're looking for. So an angle is involved. That's how we know it's trig ratios. Okay, so we got to label our sides to find out which trig ratio we're going to use. So this side here, given that that's the angle that I'm looking for, this side is of course opposite that angle. Okay, and this side here is right beside it, so that is adjacent. So we're dealing with the opposite and the adjacent. So now, which of the trig ratios deals with the angle, the opposite, and the adjacent? And it is, of course, tan. There's the angle, the opposite, and the adjacent. So it's the tan ratio that's going to help us figure this out. So write that down for ourselves. Tan of the angle is equal to the opposite over the adjacent. Right, let's fill in what we know. So the angle here is labeled a capital X, so I'll put that in for the angle, equals the opposite side is directly opposite there, and that of course is 16, divide by the adjacent side, which is this one here, which of course is 30. So there we go. Tan X is equal to 16 over 30. So I'm looking for the angle. In other words, I want to undo the tan to get X on its own. And of course, to undo the tan, I must do tan inverse. Okay, so I'll do tan inverse of that 16 over 30. Okay, so I'll do that on the calculator. So shift, remember, tan and tan inverse comes up, put your fraction, 16 on the top and 30 on the bottom, close the brackets, press equals, and there we go. And I'm going to do it to the nearest degree again. So I have 28 point, look at the number after, 0. Well, 0 doesn't make it bump up, so I'm going to leave it at 28 degrees. Okay, we're going to take a look at this question now. Now, these questions that I'm going to do from now on are a little bit trickier, okay? And I'm going to show you why they work out to be a little bit trickier. But if you're confident, why don't you give this one a go? Even if you get stuck halfway through, if you get the first few steps done correctly, remember that's always the vast majority of the marks anyway. So let's see how far you can go with this one. Press pause, and when you get stuck, then you can press play. So again, we've got a right angle triangle, we've got an angle involved, so I know I've got to use my trig ratios. But which trig ratio? So let's label the sides we're talking about in the question. Well, I'm given this 20 centimeters here, and this side is quite clearly opposite that angle, so that's O. And we're looking for this side here, which is the longest side, it's the diagonal, the one that's opposite the 90 degrees. It is, of course, hypotenuse. All right, so we should have all been able to get there. That's the very same as what we've come across in the questions before. And again, now we ask ourselves, which of the trig ratios links the angle, the opposite, and the hypotenuse? And the answer, of course, is sine. Sine of the angle is equal to the opposite over the hypotenuse. So let's fill in what we know. Well, we do know the angle here, it's 30 degrees. And we know that the opposite is 20. Divide by the hypotenuse is labelled x. Okay, so this is the first time where we've had to deal with the x on the bottom of the fraction, okay? And that causes a few little problems because we can't get x on its own when it's on the bottom of a fraction. The first thing we're going to have to do is get it from underneath the line, okay? If I've got to divide by x, immediately you're going to want to get rid of that. And the only way to get rid of divide by x is, of course, to multiply by x, okay? You never want fractions in an equation, and if they do appear, you always want to get rid of them. And to get rid of a denominator of x or divide by x, as always, you would multiply by, and in this case, of course, it's an x. Now, that will get rid of that, which is great, and we're left with 20. But of course, if I multiply the right-hand side by x, I have got to multiply the left-hand side by x as well. So now what I'm left with is x times sine of 30 degrees. Now, the only thing is it's not helping me get x on its own, but at least I don't have a divide by x, which I really can't work with. So now looking at this side, if I have x times sine 30, and of course I want to get x on its own, I basically want to get rid of the times sine 30. And to get rid of times sine 30, I'm going to divide by sine 30. But of course, if I divide the left-hand side by sine 30, I have to divide the right-hand side by sine 30. That will now get rid of that. Finally give me the x on its own, and what I'm going to do on the calculator is 20 divide by sine 30. So this is trickier because there's quite a little bit of manipulation I have to do in order to end up with that x on its own. But now that I have it, I can get my calculator, put up my fraction straight away, put 20 on the top, and then come down and put sine 30 degrees on the bottom, close the bracket, and the answer is 40. So x is equal to 40 centimeters. Okay, so this is another trickier question. So pause the video and see how you get on with this one. So we see we have a right angle triangle, we have an angle involved, so we know to use trig ratios. So let's label our sides and we'll see which trig ratio we need to use. So this side, obviously I'm given, which is 15 centimeters, is of course the side that is beside the angle. So it's the adjacent side. And this side here, it is of course the diagonal. It's the longest side opposite the 90 degrees. That side is the hypotenuse. So I want the trig ratio that connects the angle, the adjacent, and the hypotenuse. And it is of course cos. Cos of the angle is equal to the adjacent over the hypotenuse. Right, let's fill in what we know. So I know the angle, it is of course 42. So cos of the angle 42 has got to be equal to the adjacent, which is 15, divide by the hypotenuse, which of course is x. So here we go. We've got another situation with the divide by x. You can never deal with a fraction in an equation. You always want to get rid of it. So straight away, to get rid of divide by x, I'm going to multiply by x. And if I do it to that side, I've got to do it to that side. So that gets rid of that. And I'm left with x times cos 42 is equal to 15. Now to get the x on its own, I've got to get rid of the times cos 42. So to get rid of times cos 42, you divide by cos 42. But if I do it on that side, you do have to do it on that side, of course. So that gets rid of that, gives me the x on its own. And now what I'm going to do on the calculator is 15 divide by cos 42. So let's do that. And put up our fraction. And I have 15 on the top and then cos 42 on the bottom. Close the bracket equals. Okay, let's do this one to one decimal place, shall we? So 20.1, look at the number after, which is an 8. 8 will bump that one up. So it will be 20.2 and of course centimeters is our units.